Okay, let's move on with the next one. Here you can see that there's a program. One is having symbolic addressing, the other one is having relative addressing, the other one is showing absolute addressing, right? So symbolic addressing, if you look at this one, first we'll understand what the program is about. So let's open up Paint and sketch it out. You can see we are loading 0 and we are storing it in A. So if I write the pseudocode for this, it will be okay, begin A begin A equals 0, and then we are printing out ASCII number 42. Now 42 is representing asterisk, so we are printing out asterisk, right? So print asterisk, and then we are incrementing A, load A, increment accumulator, store A. So A equals A plus 1, and then we compare. So this is a loop, so it's a repeat until loop, repeat, and until A equals 5. Right now, if you check how this program is run, you can see when A is 0, it is printing the asterisk. Then here it increments A, so A becomes 1. Checks whether A is 5, no, goes and prints the asterisk again. When A is 2, prints the asterisk. 3 prints the asterisk. When it is 4, right here it will be 4. 4 equals to 5, no, so goes and prints the asterisk. And here it becomes 5. 5 equals 5, yes, so it exits. So when the value of A is 5, it will exit the loop, right? And you can see that there are 5 asterisks printed here, right? Right, so you can see the program has printed 5 asterisks, and that's what is happening here, right? So if you look at the symbolic addressing, you can see LDM, that is immediate addressing. You load 0 to the accumulator and store it in A, and then you loop here. This is where you load the asterisk and print it out, output, and then you load the value of A into the accumulator and increment it by 1, and then you store it as 1, that is incrementing the value of A, and then you compare to check whether it is 5, and then JPN, that is if it is not true, it goes back and loops. If it is true, it will exit the loop and end here. Okay, so that's symbolic addressing. Now when it comes to relative addressing, you can remember that we use something called an offset, right? We use something called an offset. So the offset value is here, right? So offset is simply how many times or how many steps more that you have added to find the new location from the base address, just like that Excel example, right? Is it 1 step away or 2 steps away? So that's what offset does, right? So you can see here at first LDM 0, so it will bring number 0, and it's going to store number 0 not in A straight away, not in a particular memory location like this absolute addressing. It is going to take the base register. Now the base register, we have to assume that it is 0 plus 10. Offset is going to be 10. It is going to store in a place where the base register plus 10 is. right, where the address is base register plus 10. So base register is 0, 10 added, so it will be 10. So it will be stored in this location where the address is 10. Now that is offset added to the base register. It loads 42, which is the asterisk, into the accumulator, and it outputs. Then it is going to be it will be output, and then again we are bringing the value that we stored as 0. Now that is in a location where the base register is added with offset 10, right, offset 10, and that's here. So it will bring 0 here, right. You can see again we are not directly accessing that location, but base register plus 10. Increment the accumulator, store it in the same location, that's BR plus 10, compare it with 5, JPN. If it is not true, this time what you have to do is you have to go back to LDM42. Now that is in number 2 here, that is base register plus 2. So this time the offset is 2. So by controlling the offset, you can jump to different memory locations. That's the advantage here, right? So you can move the program to any location, right, because it will look how many steps we have moved from the base location. Still the program will work, and then if it is true, it will end. So that's what relative addressing is. So remember, the special thing here is that we have a base register plus an offset. Offset is used to control the change of the address. Okay, right. And then here right, in this third one, absolute addressing, you can see we have the memory locations, and then we load 0 to the accumulator and store it in the memory location, which is 210. Now remember, that is the actual address that we are going to store, right, and it's the exact place. Then LDM, we load the asterisk and output it, and then we load the value in 210, which is 0, to the accumulator, increment it, store it in the same location, and compare it with 5. If it is not 5, jump to 202 and execute that instruction, and if it is true, we end it. So you can see that here, if you compare it with relative addressing, the difference is here we are looking at the exact address. How is this differ from symbolic addressing? In symbolic addressing, you can see that we are not really looking at the address, but we are just jumping into different labels and just executing the other instructions, right? But instead of the variable here, you can see STOA. Instead of the variable, we are actually referring to the memory address. Okay, because A will be representing a particular location to a memory address, right? So here we are directly accessing that memory address. It is very important that at the end of the program, control is passed back to the operating system. Otherwise, the binary pattern held in the next memory location will be interpreted as an instruction. If the content of that memory location does not correspond to a valid instruction, the processor will crash. The instruction end, this one here, signals the end of the program instruction. So that's the purpose of end. So it's just like a begin and end, right? Where we state where we start and where we end, right? Otherwise there will be confusion with the memory locations here, right? So that's why they have used the end operation here, and I have put note about the end operation in the PDF document that I'm going to give you. Right, so in the next video we'll look at indirect addressing, and then we are done with this.